Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions. At ngayon ay magkakaroon tayo ng bagong topic at ito ay ang dynamics of rigid bodies. Sa ngayon ay meron tayong outline ng magiging topic natin at ito ay mahahati sa dalawang bahagi. Una ay tatalakayin muna natin yung unang bahagi ng dynamics, yung tinatawag nating kinematics of particles. At sa mga susunod na pagkakataon ay tatalakayin din natin yung pangalawang bahagi naman ng dynamics of rigid bodies, and it's all about kinetics of particles. Sa unang bahagi ng ating discussions ay gumawa ako ng outline at ito yung aking magiging topic ng susunod nating mga discussions. Una, meron tayong introduction na siya ngayong ating gagawing discussions mamaya. Pangalawa, meron tayong discussions about rectilinear motion. Then meron din tayong discussions about curvilinear motion. Meron din tayong discussions about rectangular coordinates. At yung discussions natin about normal and tangential coordinates. Meron din tayong discussions about polar coordinates at space curvilinear motion. At sa bandang huli ng kinematics of particles, meron tayong relative motion at constrained motions of connected particles. Kung aking tatantyahin itong ating mga outlines na nakahanay sa ating discussions about kinematics of particles ay baka abutin ng more or less mga 15 discussions. Kaya kung gusto niyo masubaybayan itong mga topic natin for today's discussion about dynamics of rigid bodies, I'm encouraging you and inviting you to subscribe to this channel and share this channel to your friends so that your friends would also be notified about our uploads and discussions about dynamics of rigid bodies. At simulan natin ang ating discussion about the introduction or introductory concept about the kinematics of particles. At magsimula tayo sa ilang definition ng mga konsepto na may kinalaman dito sa ating discussions about dynamics. Una, ano ba ito tinatawag nating kinematics? Kinematics, kung pag-aaralan natin, ay isang branch of dynamics which describes the motion of bodies without reference to the forces which either cause the motion or are generated as a result of the motion. In other words, kinematic is often described as the geometry of motion. Kapag ang tinutukoy natin ay may kinalaman lamang sa geometry ng motion, walang kinalaman ang force na naging dahilan ng pagkakaroon ng motion, o kaya naman ay yung force na naging epekto ng mayroong motion, ang tawag doon ay kinematics. So magbigay tayo ng halimbawa. Halimbawa, sabihin natin, meron isang bola na binigyan ng initial velocity at a certain direction. Kung hinahanap natin kung nasan siya after few seconds, ang tawag ng kinematics. Diba? Kung hinahanap natin siya kung ano yung maximum horizontal distance that the ball would travel, kinematics ang tawag doon. O kaya kung hinahanap natin kung ano yung pinakamataas na mararating ng bola, kinematics ang tawag doon. Kasi wala pa tayong pinag-aaralan ukol sa force na naging dahilan ng motion. Kung ang pinag-uusapan lamang natin doon ay geometry of motion, then we are talking of the kinematics, which is that branch of dynamics that describes the motion of bodies without reference to the forces which either cause the motion or generated as a result of the motion. Okay? So, saan kalimitan ginagamit itong kinematics? Some engineering application of kinematics includes the design of cams, gears, linkages, and other machine elements to control or produce certain desired motion. So, kalimitan itong nakikita natin sa mga machineries kung saan ay ginagamit siya to control the motion, to change the direction of the motion, and other, They are also used in the calculation of flight trajectories for aircrafts, for rockets, and spacecraft. Halimbawa, sabihin natin, there is an object from outer space that would fall okay, sa Earth. If you are looking at where in the Earth would that hit the ground, ang tawag doon ay kinematics. Ano? So we studied the flight trajectories of an object coming from an outer space. Then we also have the definition of a kinetics. And when we say kinetics, it is the study of the relationship between the motion and the corresponding forces which cause or accompany the motion. Kapag ang tinutukoy na natin dito ay ang relation ng force at ng motion, di ba? So, kinetics na ang tawag doon. Halimbawa, sabihin natin yung bola ay binigyan ng initial velocity. Halimbawa, sabihin natin yung initial velocity ay 50 meters per second. So, ang tanong ay, ano kaya ang force na dapat i-apply doon sa bola for that ball to have that velocity of 50 meters per second? So, tandaan natin na involved na doon yung force. The force that would be needed to make or to give an initial velocity on the ball. And therefore, we are already talking of kinetics. Okay, halimbawa naman sabihin natin the ball hit the ground. And when we are talking of what is the impact on the ground of the ball while hitting? Okay, what force was induced, was created, was produced by that ball on the ground? Then we are already talking there of kinetics. Again, when we are designing, when we are describing the relationship between the force and the motion, then we are talking actually of kinetics. So we also have some definition like that of a particle. Ano ba ang definition of particle? Sabi dito, a particle is a body of negligible dimensions when dimensions of the body are irrelevant to the descriptions of its motion or the action of forces on it, then the body may be treated as a particle. Di ba, no? So, hindi nangangahulugan na ang dimension niya ay maliit lang para masabi natin particle. So, when we say particle, kapag ang dimension niya ay negligible compared to the other dimension, the other elements of motion, then that body will be treated as a particle. Oh, let me give you an example. Sabihin natin we have an airplane, a jumbo jet. Imagine you have a jumbo jet, malaki siya. As a matter of fact, it can carry more or less mga 500 persons, di ba? So malaki ang dimension niya. Pero that airplane can be treated as a particle. When we are comparing that airplane with the dimension of the path that it is traveling from one point to another. Say for example, that airplane moves from one country to the other country. Diba? So masyadong malaki na yung dimension na yun. And if we are to compare the dimension of the airplane, then the airplane will be treated then as a particle. So hindi ibig sabihin particle maliit lang, particle negligible ang dimension niya compared to the other dimensions of the motion. Okay? Okay. The next example, the next element that we will have is a rigid body. Okay? Kaya nga meron tayong title ng ating topic for today, Dynamics of Rigid Body. Ano ba itong rigid body na tinutukoy? Pag sinabi nating rigid body, it is a body whose changes in shape are negligible compared with the overall dimensions of the body, or with the changes in the position of the body as a whole. So, sabi nga, nalaman natin sa ating study of mechanics of the formable body that when a body is subjected to a force, the body may be subjected to a deformation. However, if the deformation that would be caused by a force upon the body is so small that it can be considered negligible compared to the dimension of that body, then the body may be treated as a rigid body. Or if the relative position of one part of the body remains the same when the body is subjected to an external force, then the object or the body may be treated as a rigid body. Then when we discuss with the dynamics of rigid body, hindi natin may iwasan na balikan muli yung very common concept that we have or we will be using in the course of our study, in this study of dynamics of rigid body, and that is the Newton's law of motion. There are three popular laws of motion that Newton's formulated, and this will be used in this discussion of dynamics. Una, sabi nga, a particle remains at rest or continues to move with a uniform velocity in a straight line with constant speed if there is no unbalanced force acting in. Ang ibig sabihin no, sabi niya, if a body is at rest, it will remain at rest unless it is subjected to an external force. Yun yung konsepto ng first law of motion. Or if a body is moving along a straight line with a constant velocity, it will remain traveling at that velocity unless it is subjected to an unbalanced force. It will not stop, it will not change its direction, it will not move faster, as long as it is not subjected to an unbalanced force. Yun ang ibig sabihin ng first law of motion. While the second law of motion talks of the relationship between a body that is subjected to an unbalanced force. Ang sabi dito, the acceleration of a particle is proportional to the resultant force acting on it and is in the same direction of this force. So sabi dito, if you have a body that is subjected to an unbalanced force, kung ang pag-uusapan natin ay first motion, kung walang unbalanced force, that body will remain at rest. Pero kung meron ng unbalanced force, then the body will be subjected to an acceleration. And the direction of that acceleration is in the same direction as the direction of the motion. And this law is very, very popular because this is the basis for most of the analysis in dynamics. Very common siya, very popular siya. Yan ang kalimitang ginagamit natin in the analysis, particularly in the subject dynamics. And if we are to write that concept that we have in the Newton's law of motion, for a particle of mass m that is subjected to a resultant force, when I say resultant force, this is the unbalanced force. The law says, or the law may be stated as F equals the mass multiplied by the acceleration. Na kung saan itong mass, ito yung tinatawag nating proportionality constant. This will dictate the proportionality between the acceleration and the force. And when we say proportional, as the force increases, the acceleration will also increase. If the force is directed in one direction, the acceleration will be directed in the same direction. Yun ang ibig sabihin ng second law of motion. Na kung saan in this equation or in this formula, yung F, yun yung tinatawag nating unbalanced force that is acting on the body of mass equal to m. And A is the acceleration resulting from the application of the unbalanced force F. Right? Now, the third law of motion is all about the action and reaction of two interacting bodies. And it says that the forces of action and reaction between interacting bodies are equal in magnitude, opposite in direction, and collinear in action. Ang ibig sabihin nun, kapag meron daw tayo dalawang bodies that are interacting, the two bodies are exerting a force upon the other one. And the magnitude of the force exerted by one body upon the other, na tinatawag nating action and reaction, are equal in magnitude. They are opposite in direction and collinear in action. In other words, they are lying on the same line. Newton also formulated the laws of gravity, and we call that as the gravitational law of Newton. Newton's law of gravitation. And this governs the mutual attraction between two bodies. So, ito yung maganda nating dapat maunawan. When you have two bodies, but there will be what we call force of attraction between the two bodies. And the magnitude of that force of attraction is given by the formula F equal to a capital G multiplied by M1, M2 divided by the square of R. Na kung saan itong F natin, yun yung tinatawag nating mutual force of attraction between the two particles. Yung force na ine-exert ng one body upon the other. Okay? Okay, yung G naman, tinatawag natin universal constant. And its value is equal to 6.673 times 10 to the negative 11 meter cube per kilogram second square. At yung M1, M2, yun yung mass ng dalawang particles where the mutual force of attraction is being computed. And R represents the distance between the centers of the particles. And so, if we wanted to determine the force between two objects, just have to take their masses and the distance between them. Halimbawa, the force between you and me. If you have certain mass and I have certain mass, and we are located at a distance r between us, then we can have, there will be a force that I am exerting upon you, and there is another force, also the same force that you are exerting upon me, and the magnitude will be equal to G times M1, M2 divided by the square of the distance between the two of us. Okay? So, ituloy natin, when we are talking of the effect of altitude, sabi nga, every object which falls in a vacuum at a given height near the surface of the earth will have the same acceleration, acceleration G, regardless of its mass. Ito yung konsepto na, naunawaan o na-develop na pumigil dun sa konsepto na yung daw mas malaking mass, mas mabilis bumagsak. So it was pinabulaanan na yung konseptong yun na ang mas malaking mass ay mas mabilis daw babagsak o mas malaki ang acceleration. That's not anymore true. That's actually not true. So ang sabi nito, every object which falls on a vacuum at a given height will have the same acceleration G regardless of the mass. And these results can be computed para maunawaan natin ano ba yung gravitational pull of the earth na tinutukoy natin. At yan ay makukumpute natin mula doon sa dalawang laws na formulate ni Newton. Doon sa kanyang first law of motion at doon sa kanyang law of gravitation. Sabi kasi doon sa first law of motion that second law of motion that a body that is subjected to an unbalanced force F shall be subjected to an acceleration whose direction is in the same direction as the direction of the force. While doon naman sa law of gravitation, between two objects, there is force of attraction, and is equal to the gravitational constant multiplied by M1, M2 divided by the square of the distance. Now, consider natin that we are talking of two objects. One object is any object above on the surface of the earth. And the second object is the earth itself. And so between the earth and the object, there will be what we call force of attraction. And from there, makukuha natin ngayon yung gravitational attraction of the earth upon any object. And here is how we will do it. If we are to consider the force of attraction, because the force of attraction between the earth and that object will be the same, dapat equal yan, So, but we would expect that, if the object is subjected to a gravitational pull, that's the gravitational pull of the earth. And therefore, and on the second formula that, the gravitational pull of attraction is equal to G times M1, M2 over R square, where here M1 refers to that mass of the object on earth, and ME is the mass of the earth. And R represents actually the radius of the earth. Although there could be a distance between the earth and the surface, but that distance would be very, very small. And compared to the radius of the earth, therefore, the effect of that distance from the earth's surface would be negligible, and therefore, we can consider that the distance between them simply will be equal to the radius of the earth. And so if M1 and M1 here will cancel, so we will be getting, the value of G, and G will be equal to, okay, the gravitational constant multiplied by the mass of the Earth divided by the distance or the radius of the Earth. And this actually is our gravitational attraction or gravitational acceleration, or the acceleration due to gravitational pull of the Earth. Diba? Yun yung tinatawag natin kay G. Ngayon, kung pag-aaralan natin yung G natin, yung acceleration due to gravity's Earth, Earth's gravity, and G is the universal constant, okay, na ang value niya is, I have already given a while ago, 6.673 times 10 to the negative 11 meter cube per kilogram second square. Now, paano natin malalaman yan? Makukuha yan? Kung malalaman natin yan, kung ang mass natin ay na-express, if ME will be the mass of the Earth, and through experimental measurement, it was computed to be 5.976 times 10 to the 24 kilogram. Ganyang kabigat, yan yung mass ng Earth, Yan yung mass ng Earth. And therefore, in this case, yung R sabi naman, tumutukoy sa radius of the Earth. And again, through experimental measurement, it was found to be 6.371 times 10 to the 6 meter. And if all of this shall be substituted here, so you have the gravitational constant, you have the mass of the Earth, and you have the radius of the Earth, then we shall be getting our gravitational attraction of the Earth. And this will be equal to 6.673 times 10 to the negative 11 meter cube kilogram second square multiplied by the mass, that is equal to 5.976 times 10 to the 24 kilogram, okay, divided by 6.371 times 10 to the 6 meter square. So if we will be simplifying this one, okay, yung value ng G makukumpit natin to be 9.825 meter per second square. Ito yung tinatawag nating absolute acceleration due to gravity. Diba? But we should note here that maaaring nagtaka kayo, pero bakit ang ginagamit naming value do sa lessons namin, mga topic namin, mga subject namin is 9.81. Samantalang ito, pinakita, we have 9.825. So, paliwanag natin bakit meron tayong ginagamit 9.81 at 9.825. Actually, 9.81 is just a rounded value from 9.80665. And I will explain to you saan ang galing yun. So, here is the explanation. Note natin dito na yung variation of G with latitude is easily determined from the gravitational law. Sabi yan, yung latitude ng Earth, yung naghahati sa Earth through latitude, ay may kanya-kanyang value ng G, at yan ay na-determined by the gravitational law. That if we are going to use G sub O to represent the absolute acceleration due to gravity at sea level, then the absolute value at an altitude h can be taken by the formula G times G sub O, okay, multiplied by R square over the quantity R plus H square. Na kung saan dito yung G sub O, yung tinatagating standard, absolute acceleration due to gravity at sea level. Ito naman yung R is the radius between the center of the Earth and the object. But if the object is at the Earth's surface, then it will be just treated as the radius of the Earth. While this one is where h is the altitude of the object from the Earth's surface. In this particular case, may considerable na yung height ng yung position ng object mula sa Earth, di ba? And yung G natin mababago, nagkakaroon ng variation. Habang tumataas tayo, lumiliit yung value ng G. Di ba? Liliit yung value ng G. So, at ito yung ginagamit nating formula para makuha yung G. Mamaya, ipapakita natin yung paano ito lumabas yung 9.81, which is actually from 9.80665. Okay? So, aside from that of the altitude, yung movement ng Earth, meron ding impact or meron ding epekto doon sa gravitational pull of that Earth upon the object. And this is what we call the effect of a rotating Earth. Sabi dito, the acceleration due to gravity as determined from the gravitational law is the acceleration which would be measured from a set of axes whose origin is at the center of the Earth, but which does not rotate with the Earth. So, ang ibig sabihin nun, yung ating naging basihan ng pag-compute ng G ay mula doon sa reference axis na naka-refer mula doon sa center of the Earth. However, ang treatment doon is that the Earth does not rotate, the object does not rotate with the Earth. Diba? Paano kung yung object ay nasa Earth mismo? Diba? At yung Earth ay umiikot. Ibig sabihin, if the object is in the surface of the Earth and the Earth rotates, therefore, the object rotates with the Earth. Ang tinutukoy dito na which does not rotate with the Earth are those objects that are at a very, very high altitude. That when the Earth rotates, the object is not rotating with the Earth. Katulad halimbawa ng mga satellites. Diba? Ng mga satellite that are launched in the outer space. As the Earth rotates, the satellite remains in their position. Diba? At ang computation, ibinase doon sa ganong konsepto that is referred from a certain axis that does not rotate with the Earth. Paano kung yung object is in the surface of the Earth where the Earth is rotating? Diba? Kaya if the Earth rotates, the object is rotating with the Earth. And therefore, the effect of that rotating Earth would have an effect on the value of the gravitational pull. Diba? Because the Earth rotates, the acceleration of a freely falling body as measured from the position attached to the surface of the Earth is slightly less than the absolute value. Yun ang dahilan kaya ang value na ginagamit nating G na 9.81 ay mas mababa doon sa value na ipinakita kanina na 9.825 because of the effect of the rotation of the Earth. Kung gayon, ano yung standard na value na ginagamit natin? Ano? So sabi dito, the standard value which has been adopted internationally for gravitational acceleration relative to the rotating Earth at sea level and at altitude 45 is 9.80665. Ito yung sinasabi ko na value na ginagamit natin, na rounded off to 9.81. Actually, that value is equal to 9.80665. And that value is the gravitational or the acceleration due to gravity at sea level and at altitude of 45 degrees. In English, it is equivalent to 32.1740 feet per second square. Now, when rounded off, ay ginagamitan natin na 32.2 feet per second. Ngayon, paano kung nasa ibang position tayo of the Earth at a different latitude? Halimbawa, sa equator, at latitude 30, at the North Pole, at latitude 60, and so on and so forth. So, how do we get the value of G? Would there can we use the same value of G as 9.81 na gaya ng kalimitan natin ginagamit when you are at the North Pole or when you are at the equator? So sabi dito, at other latitude, the following graph may be used to determine the standard G relative to the rotating Earth and non-rotating Earth. So ibig sabihin meron tayong graph, and this graph was developed, ito yung graph na ipapakita ko sa inyo na sinasabi pwede natin magamit na basihan to compute or to use what value of G can be used. So ipakita ko sa inyo, itong kulay pula na nakikita natin will represent the value of G at different latitudes. So yung nasa bandang iba is when the value of G is taken relative to the rotating Earth. Ang ibig sabihin, the object rotates with the Earth. And you will have here the different latitudes, So you have at 0 latitude, 30 here, 60, and at the North Pole, which is equivalent to 90 latitude. Yung sinasabing 45 degrees latitude is somewhere here, nasa gitna, somewhere dito. Na kung saan, if you will be projecting it here, ito yung lalabas na point. at pag tinin natin yung value, then the value will be somewhere here that's equivalent to 9.80665. And when you have the G relative to non-rotating Earth, when you are talking of G, okay, what G are you going to use when you are outside the Earth's surface? So you will be using these upper values of G. Okay? So, para magamit natin yan, yung graph ito, paano ba yung gamitin? Medyo palakihin natin yan para madaling gamitin. Yan ito yung paggamit. Halimbawa sabihin natin, we wanted to determine the G at sea level, and which is the standard value that we are using, ano? Yung sinasabi natin 9.81, rounded siya from 9.80665. For non-rotating Earth, okay, ang ibig sabihin yan, that the Earth, that the object does not rotate with the Earth. Okay, does not rotate with the Earth. Ano ibig sabihin, does not rotate with the Earth? But explain ko lang siya sa pamamagitan ng some konting animation dito. Nilagyan ko ng konting animation. So, halimbawa, ito yung object, ano? Ito yung Earth. Pag nag-rotate yung Earth, hindi man sumasama, hindi man umiikot yung object. Halimbawa siya satellite. So, as the Earth rotates, okay, the object remains at that position. Diba? So, ibig sabihin, ang gagamitin nating value is somewhat itong nasa ibabaw na ito. Ito nasa ibabaw na red one. What G are we going to use? So, ito yung sinasabi. At the latitude 45, ito yung latitude 45, we have 30. Ibig sabihin, bawat guhit dyan is equivalent to 10. Ito 30, 40, 50, 60. Ibig sabihin, ang 45 somewhere here. So, kung titignan natin yung latitude 45, ito yun, yung guhit na yan, no? And okay, the Earth, the object does not rotate with the Earth. Ito yung makikita natin part. So if this will be projected somewhere here, ang lalabas niyang value is yun. Yung makikita natin yan, that is 9.825. Yung na-compute natin kanina na 9.8205. Hindi ba? Samantala, kung ang gagamitin naman natin ay okay, value of G at sea level, di ba? At latitude 60 from for non-rotating Earth, that is the object does not rotate with Earth. Ano, ulitin ko lang, gano'n yung concept. Kung ikot siya, hindi mas kasama kung ikot yung object with Earth. At kunin natin yung G niya at latitude 60. Ito yung latitude 60 na tinutukoy. Ano? So if we will be getting the G here, okay, yun yung ating G, at i-project natin siya somewhere here, makakakuha tayo ngayon ng G. Okay, ang G niya is 9.8255, somewhat very close to 9.8255. Yun yung kanyang G, ano? Ngayon, paano naman kung the object rotates with the Earth, gaya ng G na ginagamit natin? Okay, ito yon. So, the value of G at sea level and at latitude 45, ito yung standard na ginagamit natin, ano? So, and referred from a rotating Earth, that is, the object rotates with the Earth. Pakita natin uli, if you have here the Earth and the object, if the Earth rotates, the object rotates with the Earth. Parang ganyan ang scenario. So, that's actually the acceleration of gravity, okay, by the Earth upon the body, okay, that rotates with the Earth. And the value of G is at standard at 45 siya. So kung titignan natin dito yung 45, ito yung 45, di ba? So tingnan natin yan. Okay, tingnan natin, ito yung dito natin titignan. And then if we project it to the left, and the value that we will be getting is somewhere at that point. And this is about, okay, 9.80665. Na kapag in-round off siya, lumalabas siya is 9.81. And this is the standard that we are using. Most books, reference materials are using kasi most of the countries are in that particular part of the earth, part of the earth. Okay? Kung medyo mababa ka, kung you are below the equator, wala kasi, equator kasi at zero, no? Okay? So, at the equator, ang value ng G natin is on 9.7 9.7, ano? Something like that. So, yun ang halimbawa. Paano kung medyo you are above the equator, somewhere above, malapit ka sa North Pole? Okay? Halimbawa, sabihin natin, gumamit tayo ng additional latitude 60. What will be the value of G at a latitude 60 when of the object that rotates with the Earth? And therefore, we'll be looking at this point. Natin itong 60 na ito, i-project natin, kumbaga, yung Earth, iikot siya with Earth, parang ganyan scenario tayo. Ito, So, when you project the 60, makita natin yung value is there. Eksakto siya, no? And that eksakto is 9.82. So makita natin yung value niya is 9.82. The value of G at latitude 60 at sea level is equal to 9.82. Oh, nasundan na? Okay, siguro mas maganda magbigay tayo ng halimbawa para maunawaan natin paano ba ginagamit yan. And let us have this example. Sabi natin, a space shuttle payload module weighs 500 Newton when resting on the Earth's surface at a latitude of 45 north. Tama, standard siya, no? Find its weight when the module is taken to an altitude of 350 kilometers above the surface of the Earth and released there without a velocity relative to the center of the Earth. Released there without a velocity. Medyo kinakailangan natin maunawaan yan. Without a velocity. Sabihin, the object does not rotate with the Earth. Ano? Okay. So, take note here that in the problem, so we have, note that for the surface level value of the acceleration of gravity relative to a rotating Earth, use 9.80665. O bagamat kung hindi man ito given, so we can naman take the value from our graph. And for absolute value relative to a non-rotating Earth, we use 9.825. Again, if this will not be given, we can use our graph. And nagkataong ipinagamit na So, okay lang siya. So again, if you have to take note of our condition, note that at the surface of the Earth, the shuttle rotates with the Earth. Tandaan natin the shuttle is at the surface of the Earth. And therefore, as the Earth rotates, the shuttle rotates with the Earth. And therefore, what standard G are we going to use? We shall be using standard G that is 9.80665. Diba? So if we have our G, therefore, we can compute. Ito yung condition kasi, yung surface nandiyan siya, ang G natin na gagamit is 9.80665. Kaya sa G na yan, malalaman natin we can compute for the mass of the Earth kasi we are given that weight of the object. So from the formula that weight is equal to the mass times the gravitational pull of the Earth, where the gravitational pull of the Earth is equal to 9.80665 as indicated by the condition that it is on the surface and at latitude of 45. And therefore, we can compute and we can solve for the mass which is equal to, we are given the weight of 500 Newton, that's equal to 500 Newton divided by 9.80665 meter per second. Lumalabas yung mass niya is 50.98581 kilogram. Ibig sabihin, yung mass ng shuttle natin ay 50.98581. At tandaan natin, ang mass naman ay hindi nababago. Ang nababago is weight because weight is the attraction of the Earth upon that object having a mass equal to m. Sa makatwid, saan man natin dalhin itong shuttle nito, its mass will remain at 50.98581. Kaya doon sa tanong na kung dalhin siya sa altitude na 350 kilometers, ano ngayon ang kanyang magiging weight, di ba? Ano ngayon ang kanyang magiging? Sa makatwid, kinakailangan natin ma-compute ano yung magiging G niya, ano yung magiging gravitational pull, gravity, acceleration due to gravity of the Earth upon the shuttle when the shuttle is brought to an altitude of 350 kilometers. Sa makatuwid, ito yung mangyayari. Sabi diyan, at an altitude of 350 kilometers above the surface of the Earth, the shuttle was released without a velocity with the Earth. Ang ibig sabihin nun, the shuttle does not rotate with the Earth. Diba? Hence, anong absolute value of G are we going to use? We will not be using anymore G which is equal to 9.80665 kundi 9.825 na. Kasi ang condition niya, nasa altitude na siya and when the Earth rotates, hindi naman gumagalaw na yung hindi na gumagalaw yung ating shuttle. As indicated that the shuttle is released there without velocity relative to the Earth. Sa makatwid, at this condition, ang G, ang gravitational pull of the Earth, standard at sea level, 45 latitude north will be 9.825. Sa makatwid, we shall be getting, take note that this G is only at the surface. Hindi pa ito yung G doon sa itaas. ito is nasa surface pa lamang. So we will be getting now the G of the gravitational pull of the Earth at the altitude equal to 350 kilometers. Kaya pag kinumpute natin ngayon siya, so what shall we do? We will be solving for the absolute G with respect to non-rotating Earth at an altitude of 350 kilometers above the surface. Ano yung formula gagamitin natin? Yung formula gagamitin natin, sabi yan, the G at that altitude shall be equal to the absolute value of G. Okay, ito yung binigay ko kanina, no? Times the quantity R square plus R, the quantity R plus H square. Na kung saan R dito is the radius of the Earth and H is the altitude of the object above the Earth's surface. And G sub O, itong G sub O, itong 9.825 na gagamitin natin. Hindi yung 9.8066 kasi at this position, the shuttle is not moving with respect to the Earth. If it is somewhere here siguro, somewhere dito, and the object rotates with the Earth, therefore, the G na gagamitin natin dito is still 9.80665 pa rin. Ano? Now, substituting the value of the radius of the Earth as well as the altitude, then we have the gravitational acceleration due to gravity at the altitude 350 kilometers shall be equal to 9.825 times 6.371 times 10 to the 6 square divided by the quantity 6.371 times 10 to the 6 plus 350,000 square. And this gives us a value of G at that altitude equal to 8.828359 meter per second square. And therefore, if we wanted to compute for the weight of the shuttle at the altitude 350 kilometers, then we use that G in computing for the weight, which is equal to M times G. Now, substituting the value of M, which is constant, that is equal to 50.98581 kilogram multiplied by 8.828359 meter per second. Therefore, the weight of the object at the altitude becomes equal to 350.121 Newton. So I have presented to you guys the first problem on some introductory concept about the dynamics of rigid bodies, particularly on the force of attraction between two objects, as well as the gravitational attraction due to the Earth's gravity. Now let us have this second problem. Okay, the second problem is all about the same concept, and it says here, what is the weight of a 500 kilogram body at the North Pole? At what altitude h above the North Pole is the weight of that body reduced to 1/2 of its Earth's surface weight or its Earth's surface value, x plus h in terms of the radius of the Earth. So, ang sabi dito, meron daw tayong object or body na ang kanyang mass ay 50 kilogram. At ipinapahanap sa atin, ano daw yung kanyang weight kung siya ay nasa North Pole. At kung dadalhin siya sa itaas altitude, certain height above the North Pole, ano daw yung distance, ano daw yung altitude, para yung kanyang weight daw ay kalahati na lamang ng weight niya kung nandun siya sa North Pole. So we will be expressing the altitude in terms of the radius of the Earth. Okay? So let's do it. Balikan natin yung concept, yung value ng G at different position of the Earth. So tinanong nga natin, ito yung equator, dito yung ating standard value, somewhere is 60, at the North Pole which is 90 degrees latitude, ito yung value. Kaya kung titignan natin yung kanyang value, makikita natin dito na yung gravitation na yung G, acceleration due to gravity, of both, an object rotating with the Earth or an object that is not rotating with the Earth ay pareho at 32.26 kung English ang pag-uusapan, o kung pag-uusapan naman natin ay SI, that's about 9.833. Yan, medyo in-round off ko na lang siguro yun. Pero that could be very, very close to 9.833. That could be very, very close. And from this, we are to solve for the weight of the object. So if we are to use this 9.833 as the acceleration due to gravity at the north pole of the Earth, therefore, the weight of the object of the Earth can be computed using the formula weight equals the mass times the gravitational pull. Na kung saan itong G nito ay yung 9.833. Hindi yung 9.81 kasi yung 9.81 is somewhere here. Eh nasa North Pole yung object, therefore we will have to use G at the North Pole which is 9.833. And so therefore substituting the value here, okay, M is the mass of the object, okay, given 500. G is what? The acceleration of gravity at the surface of the Earth at the North Pole. And that value, okay, is computed at 9.8, is taken, okay, using the table at 9.833. Now, solving for the weight of the object at the North Pole, therefore we have 500 times 9.833 meter per second squared. Therefore, our weight will be 4.9165. 9165 ito, ano? 9165 kilo Newton. Okay, that's the first, the answer to the first part of the problem. On the second problem, we are asked to solve here at what altitude h shall that object be brought so that its weight at that point, at that altitude, will be 1/2 of its weight at the Earth's surface. Diba? So if we're going to consider the weight of the object at the altitude h, diba? And because, itong tanong sir, are we going to consider that the Earth at that altitude be not rotating with Earth or will be rotating with Earth? Okay. Kung babalikan natin yung figure, okay, sabi dito, makita natin sa figure na yung ating object is rotating with the Earth or not rotating with the Earth, okay, they have the same value. Diba? They have the same value. Kaya, ibig sabihin, hindi mo na kailangang tanong pa, okay, because at this position of the Earth, the value of G, whether the Earth is, the object is rotating with the Earth or not, will be the same. Okay? And that is 9.833. But, okay, so, sabihin nun, yung value ng weight natin can be taken using mass times G sub 2. Na kung saan, the G sub 2 is the, okay, acceleration due to gravity at the altitude given h, which can be computed there, to be G sub O times the quantity R plus h squared. But what is G sub O? Yung G sub O ay equal sa G sub 1 na pinakita natin. But G sub O is equal to G sub 1 as indicated, as seen in the graph, that the acceleration for both rotating and non-rotating Earth at the North Pole are the same. So mga G sub O is also the same as G sub 1. And therefore, okay, we are to substitute for this in the formula that weight sub 2 is equal to mass times G sub 2, substituting G sub 2, which is equal to G sub O, that is equal to G sub O times R squared over R, the quantity R plus H squared. Okay? But, sabi niyan, ano yung nangyari? The altitude daw, sa altitude na yun, ang kanyang weight ay kalahati na lamang ng weight at their surface. Diba? Kaya kung babalikan natin yung ating weight, which is this one, okay, so ito lang yung ating weight, mgo r square plus r plus h square, at ilipat ko naman dito yung 0.5 of mg1 kasi ang weight niya at their surface is mg1. So you will notice that here, yung m will cancel. Tsaka yung G, kasi yung G1 naman at G sub O are the same. Kaya lumalabas dito, R square over R plus H square will be equal to 0.5. Diba? So, or simply 1/2. Pag ito sinimplify natin, this becomes equal to 2 times R square will be equal to R plus H quantity square. And if we are to extract the root of both sides, therefore this becomes the square root of 2 times R will be equal to R plus H. And then finally, solving for H here, we shall have H equals, okay, the square root of 2 R minus R. And then factoring R, we shall have H will be equal to R times the square root of 2 minus 1. And that is the value at this altitude of the object. Okay, at the North Pole, okay, its weight becomes 1/2 of the weight at the Earth's surface. Guys, I hope that you're able to follow our discussion and you're enlightened of the concept of dynamic using our introductory concept. As I have said, there will be a lot of discussion to come, to follow. If you wanted to learn more of these dynamics, okay, I am inviting you to subscribe to this channel. And if you wanted your friends to be also notified of this lecture, I would like you to share this a discussion to them. Once again, thank you very much for watching.